Welcome to AS Engineering College YouTube live session, which is meant for revision series for university examinations. Okay, today's session is continuous for the yesterday's session. Yesterday we are discussing on multiplication by t, Laplace transform of a multiplication by t. On that concept, we are discussing the problems. So one problem we already completed. So this one I have done in yesterday's class, multiplication by 2 rule. So what is multiplication by 2 rule means? Wait. Right, this is multiplication by t rule. L of t power n f of t equals to minus 1 whole power n into nth derivative of f bar of s. On this we are working problems. One problem I have discussed in yesterday. Even this also I discussed. So today this question means this problem I am going to discuss, which was given in 2018. This question was in 2020. So two problems are here. I will discuss. So here Laplace transform of t sin cube t. Laplace transform of t sin cube t means here the function f of t means like function is multiplied by t. So Laplace transform of multiplication by t rule is minus 1 power 1 into first derivative of Laplace transform of sin cube t. Okay, means L of sin cube t is nothing but f bar of s. So here sin cube t I am taking as f of t. Otherwise I will write this as so f bar of s I will take f bar of s. Okay, so here f bar of s equals to L of f of t, where f of t equals to sin cube t. Okay, L of t into sin cube t, which is under Laplace transform of multiplication by t rule. I am applying, that is minus 1 into d by ds of f bar of s, where f bar of s means Laplace transform of f of t, where f of t is sin cube t. Means here, which is equals to L of sin cube t. Okay, so this is not in elementary form, it is in higher power, here it is in a higher power form. So I am converting that sin cube t into multiple angle form, that is sin 3t equals to sin 3t equals to 3 sin t minus 4 sin cube t. So from this I am evaluating, means I am finding, I make subject sin cube t as sin cube t as 3 sin t minus sin 3t by 4. Okay, this I am using, this formula I am using. So this formula is derived from here. Sin cube t equals to 3 sin t minus sin 3t by 4. That I am applying. So L of 3 sin t minus sin 3t by 4. Okay. Sin 3t means 3 sin t minus 4 sin cube t. From that I am make subject sin cube t, which is equals to 3 sin t minus sin 3t by 4. Okay. So then I converted higher degree per means higher power term into simpler form, that is in elementary form. Now you can evaluate Laplace transform by linearity property, that is 3 into L of sin t, 3 into L of sin t minus L of sin 3t, L of sin 3t. Okay. So now I converted this sin cube t into elementary form. Now you apply the standard formulas and find the Laplace transform for these. So which is equals to 1 by 4 3 into L of sin t, 3 into L of sin t. L of sin t means L of sin a t. Formula is a by s square plus a square. In the place of a we have 1. So 1 by s square plus 1. 1 by s square plus 1. Okay, minus L of sin 3t means here 3 by s square plus a square, that is 9. Okay, clear now? L of sin 3t means 3 by s square plus 9. As sin at in the place of a we have 3. So a by s square plus a square means 3 by s square plus 3 square. So I am just bringing 3 outside as 3 is in common. So 3 by 4 into 1 by s square plus 1 minus 1 by s square plus 9. Right. So this is what. Now still you simplify this. Otherwise like this you leave it, because still we need some further calculations on this. So let us represent f bar of s equals to 3 by 4 into 1 by s square plus 1 minus 1 by s square plus 9. Okay, f bar of s I evaluated. Now after that, see I evaluated f bar of s. This f bar of s has to differentiate one time. So means in this I have to substitute. So L of t sin cube is equals to L of t sin cube t equals to minus d by ds of 3 by 4 into 1 by s square plus 1 minus 1 by s square plus 9. Okay, you bring out 3 by 4 outside, that becomes minus 3 by 4. Then d by ds of s square plus 1 is minus 2s by s square plus 1 whole square. Okay, 1 by s square plus 1 differentiation is minus 1 by s square plus 1 whole square, and s square plus 1 differentiation is 2s. And minus, again similarly here 1 by s square plus 9 differentiation is minus 1 by s square plus 9 whole square, 1 by s square plus 9 whole square into 2s, that is, and minus into minus it becomes plus. Okay, so then which is equals to if I bring minus outside, that becomes plus 3 by 4 plus 3 by 4 into 2s by s square plus 1 whole square. And when I am taking minus common, so this plus becomes minus 2s by s square plus 9 whole square. So this is what Laplace transform of t sine cube t. Therefore here, so therefore Laplace transform of t sine cube t equals to this. Okay, multiplication by t rule I have applied. Okay, so this is. Next, the second question is t square e power t sine 4t. T square e power t sine 4t. I am trying to evaluate Laplace transform of that. Okay, L of t square e power t sine 4t. L of t square e power t sine 4t. Laplace transform of this we have to find. Means this is actually under multiplication by t rule, no? So which is equals to, as t square is under multiplication, for the Laplace transform of multiplication t rule, so it becomes as minus 1 whole square into 2 times derivative of f bar of s. 2 times derivatives of f bar of s. Okay, if it is 1 time, minus 1 whole power 1 d by ds. If it is 2 times t square, power is 2, na? So minus 1 whole square into 2 times derivative. Second derivative we have to find, we have to perform. So here f bar of s equals to, L of f of t. So where f of t means e power t sine 4t I have to take. So where f of t equals to e power t sine 4t. Then I am evaluating f bar of s, that is L of e power t sine 4t. Right? So again, which is, this is an elementary function multiplied by exponential function. It is like first shifting case. We have to apply first shifting theorem. So which is equals to L of sine 4t where s shifted to s minus 1 by first shifting theorem. What first shifting theorem says? If L of e power a t f of t equals to f bar of s minus a, if L of f of t equals to f bar of s, then L of e power a t f of t equals to f bar of minus a. So if it is e power minus a t, then it becomes f bar of s plus a. So in that way, I am writing this as, actually sin a t formula is a by, that is a is by 4 here, 4 by s square plus 16 where s is shifted to s minus 1. Where s shifted to s minus 1. Okay, s minus 1. So which is equals to 4 by s minus 1 whole square plus 16, s minus 1 whole square plus 16, which is going to be what? Which is going to be otherwise next slide. It's in the next slide we go for. So which is equals to 4 by s minus 1 whole square plus 16. So then 4 by s square minus 2s plus 1. Plus 1 plus 16 means plus 17. S minus 1 whole square, a minus b whole square expansion, a square minus 2ab plus b square. So s square minus 2s and plus 1 plus 16 is going to be plus 17. Okay, this is f bar of s. This is f bar of s. I evaluated. Okay, so in this we have to substitute that f bar of s. You represent this as equation 1. If I represent, put that f bar of s in 1. Put f bar of s in 1. Isn't it? F bar of s means I evaluated f bar of s using first shifting theorem, where the function I took as e power t sin 4t, and that sin 4t is with a combination of exponential function. So I applied first shifting theorem and I got as 4 by s square minus 2s plus 17. Right. So now put in 1, that is L of t square into e power t, what, sin 4t is equals to minus 1 whole square, second derivative d square by ds square of 4 by s square minus 2s plus 17. Okay. So which is equals to minus 1 whole square is plus 1 into d by ds of, otherwise simply you can neglect of writing this plus 1 into that is going to be that only. Okay, so then d by ds of differentiation of this, you can also take 4 outside, then 1 by s square minus 2s plus 17, differentiation is 1 by s square minus 2s plus 17 whole square. 1 by s square minus 2s plus 17 whole square into s square minus 2s plus 17, differentiation is 2s minus 2. Okay, this is derivative of first derivative of this. Now we try to simplify. Here we can take 2 common. If I bring 2 outside, becomes 8 d by ds of s minus 1 by s square minus 2s plus 17 whole square. Now apply differentiation for quotient rule I am applying, that is u by v rule. So which is equals to 8 into v into means v, this I am taking as u, numerator is assume as u and denominator you assume as v into du minus u into dv by v square. So that s square minus 2s plus 17, that is v into du, differentiation of s minus 1 is 1 minus s minus 1 into s square minus 2s plus 17 whole square, differentiation you have to write, that is 2 into s square minus 2s plus 17, s square minus 2s plus 17 whole square differentiation is 2 into s square minus 2s plus 17, and again s square minus 2s plus 17 differentiation is what? 2 into 2s into 2 whole divided by s square minus 2s plus 17 whole power 4, right? So here still we can do further simplification, which is equals to, so 8 into, now s square minus 2s plus 17, and here we have s square minus 2s plus 17, and here also we have s square minus 2s plus 17. If I bring out, so here a square is there, sorry, because v is s square minus 2s plus 17 whole square, na? So if I take s square minus 2s plus 17 common, so what will be left? Common, and if I cancel with the denominator, so then s square numerator will be s square minus 2s plus 17, because into 1 is there, that will be the same only will get. Okay. Next, this went outside. S square minus 2s plus 17 went outside and got cancellation. So s minus 1 into 2s minus 1. Means if I take 2 common, s minus 1 into s minus 1 means s minus 1 whole square. That is minus 2 into s minus 1 whole square by s square minus 2s plus 17 whole cube. As I took s square minus 2s plus 17 common from the numerator, and that got cancelled with the denominator, so the denominator is left by this cube. Now you try to simplify the numerator part. S square minus s square, here you will get s minus 1 whole square means s square, otherwise I will write that one, s square minus 2s plus 17 minus s minus 1 whole square means s square minus 2s into 2 plus 2s plus 4s plus 1 into minus 2 divided by s square minus 2s plus 17 whole cube. S minus 1 whole square, s minus 1 whole square is s square minus 2s plus 1. I have to multiply this by 2 and with by my negative sign. So minus 2s square plus 4s minus 2 I am writing. Okay. Now which is equals to 8 into s square minus 2s square is minus s square, minus 2s plus 4s is plus 2s, and plus 17 minus 2 is plus 15 by s square minus 2s plus 17 whole cube. Okay. So this is the Laplace transform of a given function. So therefore L of t square e power t sin 4t is equals to 8 into minus s square plus 2s plus 15 by s square minus 2s plus 17 whole cube. So this is the answer. Okay. So likewise we can find out Laplace transform of t square e power t sin 4t. Multiplication by t square, so I applied by multiplication rule of Laplace transform, and a bar of s. and at f bar of s I evaluated. On evaluation of f bar of s I applied first shifting theorem application. First shifting theorem I applied since the function is with exponential e power t, right? So this is the one question, and it's for a long answer type. Long answer type, it's maybe for 6 or 7 marks question. Okay. Next we will see next question. Means next rule, that is division by t. Laplace transform a function with the division by t, f of t by t. Means this is a quotient function used to call L of f of t by t. So L of f of t by t equals to integration s to infinity f bar of u du. Okay, Laplace transform of quotient function equals to integration of Laplace transform function. That is f bar of u is nothing but f bar of s. F bar of s. As limits are provided in s terms, so I took different notation, that is f bar of u du. That's it. Okay. So using this rule, we are going to solve some problems. On this also, multiplication by t and division by t, there are so many questions asked in university examinations, right? See this, e power minus t by sin t by t. This is the Laplace transform of e power minus t sin t by t. As per division rule, division means Laplace transform of divided by t, which is equals to integration s to infinite f bar of u du. Okay, where f bar of s equals to, where f bar of u equals to f bar of s only, where f bar of u equals to f bar of s only. So to evaluate this, you require f bar of s. So here f bar of s equals to L of f of t. Here f bar of s equals to L of f of t. Where f of t equals to what? What we take? Otherwise here f of t equals to means, otherwise let us take f of t equals to e power t sin t. F of t equals to e power t sin t, which is equals to L of e power t sin t. Okay. So here I have to apply first shifting theorem, as sin is with the exponential combination. So L of sin t in which s is shifted to s minus 1, which is equals to L of sin t is a by s square plus 1, that is 1 by s square plus 1, 1 by s square plus 1 with s is shifted to s minus 1. Okay, so when I shift s to s minus 1, that becomes 1 by s minus 1 whole square plus 1. Okay, this is f bar of s. Okay, this f bar of s we use here to evaluate Laplace transform of this. So then Laplace transform of e power t sin t. Laplace transform of e power t sin t. Right? So Laplace transform of e power t sin t by t. Okay, so which is equals to integration s to infinite. What is f bar of s here? 1 by s minus 1 whole square. 1 by s minus 1 whole square plus 1. 1 by s minus 1 whole square plus 1 into ds, or you have to write in u form, no, sorry. So here a bar of u means, what do you write here? A bar of u means 1 by u minus 1 whole square plus 1 into du. Because where a bar of u equals to a bar of s I took. So this a bar of s I am writing in terms of u minus 1. So which is equals to tan inverse 1 by x square plus 1 dx. Integration of 1 by x square plus 1 dx is tan inverse, no? In that sense, tan inverse of u minus 1. Okay, over the limits s to infinite. Over the limits s to infinite. So which is equals to tan inverse infinite minus tan inverse s minus 1 on applying the limits. So tan inverse infinite is pi by 2. So pi by 2 minus tan inverse s minus 1, which is equals to cot inverse s minus 1. This is Laplace transform of e power t sin t by t. Okay. This one. Otherwise I will write here, that is cot inverse, otherwise I will write in the next slide. I will write this in next slide. Okay. So therefore, L of e power t into sin t by t. Okay, L of e power minus t, na? Okay, e power minus t, okay, sorry, s plus 1 I have to change. Okay, sorry, s plus 1, that's it. E power minus t, I took only e power minus t. So e power minus t means s is shifted to s plus 1. S is shifted to s plus 1 as per the first shifting theorem. Okay, here e power minus t. Okay, so s is shifted to s plus 1, not s minus 1, sorry. So now I am just writing, which is equals to cot inverse s plus 1. Cot inverse s plus 1. Pi by 2 minus tan inverse of s plus 1 is cot inverse s plus 1. Right? So this is Laplace transform of e power minus t sin t is equals to cot inverse s plus 1. Once again, I took here only e power t, so what I shifted s to s minus 1 like that I said. Sorry, here we have my e power minus t, na? So s is shifted to s plus 1 and proceed. Okay, this is one question. Next, cos h2t into sin 2t by t. So Laplace transform of cos h2t into sin 2t by t. Right. So here also division by t. So it is integration s to infinite f bar of s ds. So here f bar of s equals to, Laplace transform of f of t. Here f bar of s equals to Laplace transform of f of t, where f of t equals to cos h 2t into sin 2t. Cos h 2t into sin 2t. Now I am going to evaluate the Laplace transform of cos h 2t into sin 2t. So now I have to evaluate of this. So here cos h 2t is L of cos h 2t means e power 2t plus e power minus 2t by 2 into sin 2t. Okay, so hyperbolic function, I am just writing a hyperbolic function cos h 2t by e power 2t plus e power minus 2t by 2 into sin 2t. You bring out by 2 outside. So then L of e power 2t sin 2t. I am directly writing means linearity property I am applying here, e power 2t into sin 2t plus L of e power minus 2t into sin 2t. Right. Again we apply first shifting theorem here. So which is equals to 1 by 2 into, I am applying first shifting theorem, that is L of sin 2t, L of sin 2t, where s is shifted to e power 2t na, so then s shifted to s minus 2 plus L of e power minus 2t sin 2t means L of sin 2t where s is shifted to s plus 2, where s shifted to s plus 2 by first shifting theorem, Okay. Now which is equals to 1 by 2 sin at means a by sin square plus a square. A means 2 here, 2 by s square is shifted to s minus 2, so s minus 2 whole square plus a square, that is 2 square, plus similarly that also 2 by s plus 2 whole square plus 2 square. Okay, here s is shifted to s plus 2 because here sin 2t is with e power minus 2t. With power e power minus 2t, s is shifted to s plus 2t, s plus 2, and here with the s e power 2t, so s is shifted to s minus 2. That is what I wrote. So which is equals to 1 by 2, you can take 2 common, so then that 2 get cancelled and gives by 1. 1 by, if you simplify this, what do you get? 1 by s square. Actually what is required here? So this is required na? So better keep like this only. 1 by, if I bring 2 square common, so 4 into s minus 2 by 2 whole square plus 1. So 2 square I am taking common, so then it becomes s minus 2 by 2 whole square plus 1, plus even here also 1 by 4 into s plus 2 by 2 whole square plus 1. So which is equals to 1 by 4, you can take it out. So then what do you write here? Why I am writing like this? Because here you have to perform integration. So if I write like this, it will be helpful for evaluation of integration in further steps. So which is equals to 1 by 4 into 1 by s minus 2 by 2 whole square plus 1 plus 1 by s plus 2 by 2 whole square plus 1. This is f bar of s. This is f bar of s. Okay. Once again, here f of t is cos h2t sin 2t, and cos h2t sin 2t I simplified, and I am writing as e power 2t into sin 2t plus e power minus 2t into sin 2t by 1 by 2 is there, that I am bringing outside. So then I am applying linearity property for this, and I separately took the Laplace transform. Then it becomes L of sin 2t where s shifted to s minus 2, and L of sin 2t where s shifted to s plus 2. Now L of sin 2t formula I wrote where s shifted to s minus 2, give in the place of s by s minus 2, and similarly here f by s plus 2. So likewise I simplified. Okay. Now I have to substitute here. Of course, so for the convenient I said you have to take this as f bar of u. So f bar of u du I am taking. So where f bar of u equals to f bar of s. So in the place of f bar of u I am taking f bar of s. For the sake of convenience I am writing that. So then L of cos h2t into sin 2t by t is equals to integration s to infinite. F bar of s is this. This is 1 by 4 that I am writing outside into 1 by s minus 2 by 2 whole square plus 1 plus 1 by s plus 2 by 2 whole square plus 1 into, sorry, here I have to write u now, sorry, because I took as so u minus 2 whole square, u plus 2 whole square into du. Okay. So then which is equals to, otherwise I will go for next slide, otherwise right here, which is equals to 1 by 4 into, this is like 1 by x square plus 1. X square plus 1 in the place of 1 by x square plus 1 means tan inverse. 1 by x square plus 1 means tan inverse. So in the place of x we have u minus 2. U minus 2 by 2. U minus 2 by 2 we have. So then this I am taking as some t. So then du by 2. The on differentiation u by 2, u minus 2 by 2 equals to t, then differentiation of u minus 2 by 2 is du by 2 equals to dt. So then du equals to what you get? 2 dt. This substitution I am using. This substitution I am using to evaluate that. So then which becomes 1 by 4 integration s to infinite, of course. So see, when I convert u into t, I have to change the limits, of course. That limits I will tell you later. 1 by, so u minus 2 by 2 I am taking as t square plus 1 Okay, plus, wait, I will do in the next slide better. I will do this in the next slide. So which is equals to 1 by 4 integration s to infinite 1 by u minus 2 by 2 whole square plus 1 into du plus 1 by integration s to infinite. I am separating the integration 1 by u plus 2 by 2 whole square plus 1 into du. So in this case, I will take u minus 2 by 2 is equal to t. So in this case, I will take u plus 2 by 2 equals to some s or other variable as x you take x. Okay, so from this du equals to what you get 2 dt. As I said previously, u minus 2 is equal to 2t, then differentiation of u minus 2 is equal to 2t given by du equals to 2 dt. U minus 2 is equal to 2t, you will get the differentiation on both sides, then du equals to 2 dt you will get. Similarly here also du equals to 2 dx. So I have to use separate substitutions, as we have here u minus 2, there u plus 2. Okay, which is equals to 1 by 4 integration C. So in the place of u s, in the place of u, if I give s minus 2 by 2, s minus 2 by 2 you will get, of course, s minus 2 by 2 1 by t square plus 1 into dt, where I did somewhere. Okay, plus to infinite integration, again this will be where t u give by s, it becomes s plus 2 by 2, and u given by infinite, it is going to be infinite 1 by x square plus 1 dx, 2 dx, here 2 dt. So I am taking 1 by 4 and I am taking 2 common from all. I am taking 2 taking from all. So which is equals to s minus 2 by 2. It is a function s, no? So I used to write by s. It is a function s, so I am writing as s to infinite 1 by t square plus 1 into dt plus, even this also I am taking in function of s. So integration s to infinite 1 by x square plus 1 dx. Okay, so which is equals to 1 by 4, of course 2 to get cancelled, so it becomes 1 by 2, 1 by 2, 1 by t square plus 1 integration is tan inverse t, over the limits s to infinite, where s is a function in terms of s. So I am just writing s minus 2 by 2 in terms of s, plus this is tan inverse x, where s where the limits are over the limits, limits are s to infinite, which is equals to 1 by 2 into, if I apply the limits, tan inverse infinite minus tan s, okay, plus tan inverse infinite minus tan inverse s. So which is equals to 1 by 2 into tan inverse infinite is pi by 2, pi by 2, pi by 2 minus tan inverse s plus pi by 2 minus tan inverse s. So which is equals to 1 by 2 into, we write this as cot inverse s, and plus this is cot inverse s. Right? Is it correct? Once I will check from the beginning. I had some s minus 2 a by s minus 2 whole square plus 2 square plus, okay, then here we can take 2 square common, it becomes s minus 2 whole square, right? So here s minus 2 by 2, s plus 2 by 2. We have different terms we are getting, that I am reducing into in terms of u, right? So here I am taking with some other variables. So better here you represent s1 and s2. Here s1 and s2, where s is s minus 2 by 2, s is s2 is s plus 2 by 2, s is s1 is s minus 2 by 2, s2 is s plus 2 by 2. So then tan inverse of s1, tan inverse of s2. Okay. So then tan cot inverse of s1, cot inverse of s2. So this is what Laplace transform of cos h 2t sin 2t by 2. So this is Laplace transform of, therefore, so Laplace transform of cos h 2t into sin 2t by t is equals to 1 by 2 cot inverse s1 plus cot inverse s2. Okay. We here, how I am writing this is, means pi by 2 minus tan inverse x is, pi by 2 minus tan inverse x is cot inverse x. No, similarly I am writing that one. Okay. Pi by 2 minus tan inverse means cot inverse plus cot inverse x plus tan inverse x is pi by 2. No? So from that I am writing that as pi by 2 minus tan inverse s1 is cot inverse s1, pi by 2 minus tan inverse s2 is cot inverse s2. Okay. So once again, so Laplace transform of cos h 2t sin 2t by t, so which is equals to integration s to infinite f bar of u du I am taking. So here cos h 2t means we have 2, means e power 2t plus e power minus 2t by 2 into sin 2t. So we are getting two different forms, means here it is exists in terms of s minus 2, it is exists in terms of s plus 2. That is why I am having some means substitution problem here. That is what I got some small confusion. I hope here I made it clear, right? Okay. So s minus 2 by 2 is one form, s plus 2 is another form. So I used a substitution, I used the separate substitution, and I went for evaluating the Laplace transform. Okay, like this. So where s1 means at last you can also write 1 by 2 cot inverse. What is s1? I assumed this now, s minus 2 by 2. That you can write at last, s minus 2 by 2 plus cot inverse s plus 2 by 2. So this is Laplace transform of that. Okay, right? Next, so Laplace transform of e power 2t sine cube t by t means L of e power 2t sine cube t by t. L of e power 2t into sine cube t by t means this is equals to integration s to infinite f bar of s ds or f bar of u du, f bar of u into du. So where f bar of u equals to, where f bar of u equals to f bar of s. So here f bar of s I am taking as, here f bar of s, here f bar of s equals to L of f of t. Here f bar of s equals to L of f of t. That is L of e power 2t sine cube t. So here where f of t equals to what we have to take? E power 2t sine cube t. Okay, so again I have to apply first shifting theorem, that is L of sine cube t equals to s shifted to s minus 2. So it is in a higher order form, So sine cube t means, I already said, sine 3t is equal to 3 sine t minus 4 sine cube t. So this is the formula for sine 3t. So from this sine cube t we can evaluate as 3 sine t minus sine 3t by 4. Okay, so 3 sine t minus sine 3t by 4, and where s shifted to s minus 2. Here sine 3t, here sine 3t. Okay, here L of a function by t equals to integration over s to infinite f bar of u du, where f bar of u means f bar of s I am taking. Now I am going to evaluate f bar of s, because which is required to evaluate this integration. Now which is equals to 1 by 4 into L of, again I'm just going to apply linearity property here. So 1 by 4 into 3 into L of sin t, 3 into L of sin t minus L of sin 3t, L of sin 3t, which is s shifted to s minus 2. Okay, so now which is equals to 1 by 4 into 3 into L of sin t means a by s square plus a square, that is 1 by s square plus 1 minus L of sin 3t means 3 by a by means 3 by s square plus 9, where s shifted to s minus 2, where s shifted to s minus 2. So which is equals to 1 by 4, 3 into 1 by s shifted to s minus 2, that is s minus 2 whole square plus 1 minus 3 by s minus 2 whole square plus 9. Okay. So which is equals to 1 by 4, which is convenient for, this form is convenient for evaluating the integral which we required in the beginning. So to evaluate this integral, this form is convenient, but here s minus 2 whole 1 plus s minus 2 whole square I required. So for that I am taking 9 common, it becomes s minus 2 by 3 whole square plus 1. I am taking 9 common, no. So 3 divided by 9 is 1 by 3 will be left. So here I am taking 9 common, otherwise I will write here. So here I will write, so 3 into 9, 3 by 9. When I am taking 9 common here, if I take 9 common, so s minus 2 whole square by 9, we can write as s minus 2 by 3 whole square. So 3 ones, 3 threes. So 1 by 3 like that it comes. So which is equals to 1 by 4 into, so 3 into 1 by s minus 2 whole square plus 1 minus 1 by 3 into 1 by s minus 2 by 3 whole square plus 1. So this is f bar of s I will take to find the Laplace transform given function. Okay. So now L of e power 2t sine cube e power 2t sine cube t by t equals to integration s to infinite. So I am representing by f bar of u du na. So this I am representing by, so 1 by 4 I will take outside, 3 into 1 by u minus 2 whole square plus 1 into du, otherwise I will write whole. First 1 by u minus 2 by 3 whole square plus 1 into du. Okay. So which is equals to, so which is equals to 1 by 4 integration, so 3 into 1 by integration s to infinite 1 by u minus 2 whole square plus 1 du minus 1 by 3 integration s to infinite 1 by u minus 2 by 3 whole square plus 1 into du. Okay. So which is equals to 1 by 4 into 3 into, this becomes tan inverse u minus 2 minus 1 by 3 into, okay. So this is also like 1 by x square plus 1, it becomes a tan inverse u minus 2 by 3. So in the place of x we have, means in the place of x square we have u minus 2 by 3 whole square. So if I take u minus 2 by 3 as x, then du by 3 is equals to dx. From this du equals to 3 dx. So if I write here 3 dx, 1 by x square plus 1, for example, means I am writing here 1 by x square plus 1 into 3 dx. So 3 will come outside, then 3 into integration 1 by x square plus 1, that is tan inverse x. So this going to be given as into 3. Otherwise I will explain this. I will explain this how we substitute. So minus 1 by 3 into integration s to infinite. Here I am taking 1 by u minus 2 by 3 as some x square plus 1 u minus 2 by 3 is equal to some x if I take. What do you get here? Differentiation of u minus 2 is du equals to 3 dx. So in the place of du, I can put as dx. So 3 dx. So 3 dx I am writing. And if I put s minus 2 by 3 you will get here. S minus 2 means for x limits s minus 2 by 3. And if I put u by infinite, u minus 2 by 3 means infinite you will get only. For infinite, x is also going to be infinite. For u is infinite, x also tends to infinite. Right. So this is the substitution I am using here. U minus 2. Here I will write u minus 2. So u minus 2 by 3 is equals to x. Then du is equal to 3 dx. This substitution I am using for evaluating the last integral. So which is equals to 1 by 4 3 into, of course here I have to write the limits for this s to infinite, 3 into tan inverse u minus 2 minus 1 by 3 for this tan inverse x I am writing. Here the limits are what? This 3 get cancelled, no? So 1 by 3 will not come. S minus 2 by 3 to infinite. Okay. So which is equals to, here also s to infinite, limits are s to infinite, 1 by 4, 3 into upper limit is going to be tan inverse infinite minus lower limit is tan inverse s minus 2. Similarly, minus upper limit is tan inverse infinite. Okay. Minus tan inverse s minus 2 by 3. Okay. So then tan inverse infinite, okay, wait, here will not get cancelled as we have. So here tan inverse infinite only will get tan inverse infinite. Here also tan inverse infinite. Now you try to simplify. Now try to simplify this. So which is equals to 1 by 4. So 3 into tan inverse is going to be 5 by 2. 5 by 2 tan inverse infinite is pi by 2 minus tan inverse s minus 2. Okay. Minus into 3 is there, minus tan inverse infinite is pi by 2, tan inverse of s minus 2, tan inverse of s minus 2 by 3. Okay. So which is equals to 1 by 4. Pi by 2 tan inverse of s minus 2 means 3 into cot inverse of s minus 2 minus pi by 2 minus tan inverse of s minus 2 by 3 means cot inverse of s minus 2 by 3. So this is, okay. So 3 into tan inverse of infinity means pi by 2. Pi by 2 minus tan inverse of s minus 2 means cot inverse of s minus 2. And this also pi by 2 minus tan inverse of s minus 2 by 3 means cot inverse of s minus 2 by 3. So this is the Laplace transform of e power 2t, Laplace transform of, therefore Laplace transform of e power 2t sine cube t by t equals to 1 by 4 integration 3 into cot inverse of s minus 2 minus cot inverse of s minus 2 by 3. Okay, this is right. So once again, e power 2t sine cube t by t equals to f bar of u du, where f bar of u is taken as f bar of s. Here I am just trying to evaluate f bar of s using Laplace transform, where f of t I took as e power 2t sine cube t. So sine cube t is in a higher order form that I represent in elementary form and multiplied by e power 2t. So s is shifted to s minus 2. So 3 into, I just applied a linearity property here. By applying linearity property here, linearity property I applied here. Okay, so 3 into L of sin t minus L of sin 3t, where by 4 is then that I am bringing outside. So L of sin t formula is 1 by s square plus 1 multiplied by 3, and L of sin 3t means 3 by s square plus 9, and where s is shifted to s minus 2. So that I am applying, s is shifted to s minus 2, that I am applying. So here, for evaluating integration properly, I am just arranging in this manner. I am trying to arranging in this manner for evaluating this integration easily. So what I just kept this this f bar of s in terms of u, and correspondingly I evaluated. Okay, so this is 3 into, here 3 into 1 by s minus u minus 2 whole square plus 1 du. Here 1 by 3, 1 by u minus 2 by 3 whole square plus 1 is there. Na? For this I need some substitution. Then only you can understand to evaluate. So that substitution I used, u minus 2 by 3 is equal to x I used, and I substituted the limits. Okay, in this way you can evaluate Laplace transform of e power 2t sine cube t by t. Right. Next, 1 minus cos t by t square. So Laplace transform of 1 minus cos t by t square. So which is equals to double integration s to infinite f bar of u du into ds. So where f bar of right. So now which is equals to integration, where f bar of s equals to, where f bar of u equals to f bar of s I am taking, where f bar of u equals to f bar of s I am taking. So now here f bar of s equals to f bar of s equals to, here f bar of s equals to L of f of t, L of f of t, where L of f of t equal, where f of t equals to, where f of t equals to 1 minus cos t, where f of t equals to 1 minus cos t, which is equals to L of 1 minus cos t. Okay, So I am just applying linearity property L of 1 minus L of cos t. So L of 1 is 1 by s, L of cos t is s by s square plus 1 as per standard formula. This is f bar of s. This is f bar of s, right? Now I have to use that L of 1 minus cos t by t square is equals to integration s to infinite, integration s to infinite. F bar of u means 1 by u minus 1 by, s by s square means u by u square plus 1 into du I am writing, I am taking into ds. See, in this f bar of u I required, f bar of u is what I am taking, f bar of s, that I am trying to evaluate. I evaluated f bar of s. After evaluating f bar of s, which is used for evaluation of integration for Laplace transform of 1 minus cos t by t square. So which is equals to integration s to infinite, 1 by u du integration is log u. Okay, so u by u square plus 1. If I multiply this by 2 and divide by 2, so if I multiply by 2 and divide by 2, if I multiply this by 2 and divide by 2, so it is going to be 2u, no? So differentiation of denominator is going to be 1 by 2 log u square plus 1 will come. Okay, means u by u square plus 1 is there. I am just multiplying by 2 into 1 by 2. Multiplying by 2 and divide by 2. Get rationalize. And you apply integration for this. So this is f dash of u and this is f of u. So integration of f dash of u by f of u is log u, na? So that is log u square plus 1 followed by 1 by 2. Over the limits s to infinite. Over the limits s to infinite ds. So which is equals to integration s to infinite. So here I am trying to simplify this log of u by half log u square plus 1 means u square plus 1 under root. Log u minus half log u square plus 1 I am writing as log of u by log of u by log of u by root of a square plus 1. As half goes to means half log u square plus 1 is going to be log of root of u square plus 1. So in that way I just wrote that one. Okay. So the limits s to infinite ds. Now you take the limits integration s to infinite. If I apply upper limit, it is going to be 0 because see log u root of e square plus 1 means if I take u square, if I bring out from the root, it becomes u into root of 1 plus 1 by u square. So u get cancelled. So log of means log of 1 by root of 1 plus 1 by u square you will get. So when for the limit infinite, that is going to be 1 log 1. Log 1 is 0. So for upper limit it is going to be 0 and lower limit it is going to be log s by root of s square plus 1 into ds. Okay? Into ds. Otherwise, I will write this in the next slide. So which is equals to minus integration s to infinite log s by root of s square plus 1 into ds. Now we have to evaluate. First, we have double integration. That lower integration I evaluated, and outer integration I am trying to evaluate. So which is equals to minus integration s to infinite log s by root of s square plus 1 means log s minus log root of s square plus 1 into ds. Means log a by b, log a minus log b form I wrote. Root of s square plus 1, what we can write? Root of s square plus 1. Root of s square plus 1 means 1 by 2 log of s square plus 1. 1 by 2 log of s square plus 1. So now you evaluate by using integral by parts, that is log s minus 1 by 2 log of s square plus 1 into, I am taking 1 into ds. For applying log means integral by parts formula, I am taking into 1 because this is u and v for to make uv rule under integral by parts. In the place of v I am taking 1. So which is equals to minus integration of uv du. So uv dx, how you write? U into, u means this total log s minus 1 by 2 log of s square plus 1. Okay, this is u into integration of v dx, that is 1 ds, that is s, minus integration of du, differentiation of this 1 by s minus 1 by 2 into log of s square plus 1, differentiation is 1 by s square plus 1 into 1 by s square plus 1 into s square plus 1, differentiation is 2s. Okay, into s ds. This is u and this v, integration of v dx minus differentiation of u into v. Integration by parts I applied. So which is equals to, here I will write because next slide means this calculation leads to so for this I will write s to infinite. For this I will write the limits s to infinite. This minus is common all on whole. Minus is common for a whole term, as this minus is common for all the terms. So now which is equals to minus so this I am going to write as log s by root of s square plus 1. S by root of s square means s log s minus of log s square plus 1 we can write as log of s by root of s square plus 1 into s. Into s I am writing this over the limits s to infinite. Okay, minus minus here s into s will get cancelled, s into s is get cancelled, integration s to infinite 1 minus, and this 2 get cancelled. So s square plus 1 into ds. Okay, so which is equals to minus. So that minus symbol is common in all. So minus For upper limit, this one is going to be 0 for upper limit. S into log of s by root of s square plus 1, as s into log of 1 by 1 plus 1 by s square. Its expansion and applying limit, the term is going to be 0 for upper limit. So 0 minus for lower limit that will be asked is, for lower limit that will be asked is log s into log s by root of s square plus 1. So this is some, okay. So for upper limit it is going to be 0, for lower limit it is s into log of s by root of s square plus 1 minus integration s to infinite 1 minus, I am just adding 1 and subtracting 1, s square plus 1 minus 1 by s square plus 1 into ds, into ds, into ds, into ds. Okay. Next slide, which is going to be equals to minus integration minus s into log s so here it is not small technical issue, please. Small technical issue, small. right? Sorry for the disturbance. So next, minus of right, minus of s into log s by root of s square plus 1 minus integration s to infinite 1 minus 1 minus s square plus 1 means here you will get 1 minus 1 s square plus 1 by s square plus 1 is going to be 1 minus 1 by s square plus 1 into ds. Once again 1 minus s square, here s square we have, for that I am adding 1 and subtracting 1. So s square plus 1 by s square plus 1 is 1 minus 1 by s square plus 1, that I am writing minus 1 by s square plus 1. This 1 get cancelled. So minus into minus plus, which is equals to minus of minus s log of s by root of s square plus 1 minus integration s to infinite. So here minus into minus is going to be plus, plus into minus is minus, s to infinite 1 by s square plus 1 ds. Okay, so minus into minus plus, plus into minus is going to be minus, integration s to infinite 1 by s square plus 1 ds. This is whole, which is equals to minus into minus plus s into log, I am writing this as s square by s square plus 1. Under single root I am writing this s, I am writing as s square, and s square plus 1 under whole root minus, minus into minus is going to be plus, tan inverse of s over the limits s to infinite. 1 by s square plus 1 is integration of 1 by s square plus 1 ds is tan inverse of s. So which is equals to s into log of, we can write this as s square plus 1 by s square whole power 1 by 2 with the negative sign. Minus s means I am just log of s square by root of s square by s square plus 1 I am writing as log of s square plus 1 by s square whole power 1 by 2. For simplification purpose I am just writing like this, plus tan inverse infinite minus tan inverse s. So which is equals to minus s, that 1 by 2 comes outside, minus 1 by 2 log of 1 plus 1 by s square plus tan inverse of infinity is pi by 2 minus tan inverse s. So which is equals to minus s by 2 into log of 1 plus 1 by s square plus cot inverse s, cot inverse s. So which is equals to cot inverse s minus s by 2 log of 1 plus 1 by s square. Okay, see once again here for the upper limit this term is going to be 0, minus for lower limit will be as it is, minus 1 minus s square by s square plus 1, that I simply converted like this. Like this I simply converted. Like this I converted. Okay. So now minus of minus of s into log of log of s by root of s square plus 1 minus integration s to infinite, that one I'm writing as 1 minus of 1 minus 1 by s square plus 1. This I simplified and I wrote like this. Okay, on simplification you will get this as 1 by s square plus 1 followed by minus. Okay, so then minus of minus s into log s. This s by root of s square plus 1 I am writing as root of s square by s square plus 1. So this root is nothing but power 1 by 2. That power 1 by 2 comes to coefficient, under coefficient for the logarithm as per the logarithm properties. So minus s into 1 by 2 is minus s by 2 log of 1 plus 1 by s square, and tan inverse s over the limits s to infinity is tan inverse infinity minus tan inverse s, which is going to be pi by 2 minus tan inverse s, as tan inverse is infinity is pi by 2. Pi by 2 minus tan inverse s is cot inverse s. So minus s by 2 into log of 1 plus 1 by s square is cot plus this I am writing as cot inverse s minus s by 2 into log of 1 plus s square. Otherwise you can also write like this and you can leave. So like this also means you can write s into log of root of s square plus 1 as it is, plus tan inverse, cot inverse means we can write this as cot inverse s into log of root of s square by s square plus 1 plus cot inverse s you can write. Okay. Next, Laplace transform of derivatives. L of f of t equals to f bar of s, then L of f dash of t equals to s into f bar of s minus f of 0. So this Laplace transform rule we have to follow. So here Laplace transform of second derivative is going to be s square into f bar of s minus s into f bar of f dash of 0 minus f of 0. Laplace transform of a triple derivative is going to be s cube into f bar of s minus s square f bar of 0 f of 0 minus s into f dash of 0 minus f double dash of 0. So similarly for nth derivative we can write. Okay. So now let us evaluate Laplace transform derivative of the function. L of means here f of t equals to e power minus 5t, then f dash of t equals to minus e power minus 5t, minus 5 into e power minus 5t, means the differentiation of e power minus 5t is minus 5 into e power minus 5t, right. Now L of f dash of t equals to, what is we have? L of f dash of t equals to s into f bar of s minus f of 0, s into f bar of s minus f of 0. Okay. So here what is f bar of s? F bar of s means L of f of t. F bar of s means L of f of t. So which is equals to L of f of t means e power minus 5t. That equals to 1 by s plus 5. This is a standard form formula. F bar of s equals to 1 by s plus 5. So which is equals to s into 1 by s plus 5 minus f of 0. What is f of 0 you will get here? F of t is e power minus 5t. F of 0 is e power minus 0. Means e power 0, it is going to 1. If I put t by 0, e power 0 will get is 1. So minus 1. So which is equals to s by s plus 5 minus 1. Okay. So which is equals to minus 5 by s plus 5. This is L of f dash of t. Okay. S means L of f dash of t means s into f bar of s minus f of 0. Where f bar of s means L of e power minus 5t. That is f bar of s equals to 1 by s plus 5 by standard formula. By elementary functions we have this. So that I am substituting in the place of f bar of s, I am putting 1 by s plus 5 minus 1. So on simplifying you will get s by s plus 5 minus 1 is going to be s minus of s plus 5. S get deducted and minus 5 will be left, minus 5 by s plus 5. Similarly f double dash of t, L of f double dash of t. L of f double dash of t is equals to s square into f bar of s minus s into f of 0 minus f dash of 0. Okay. Minus f dash of 0. So you know that f bar of s equals to 1 by s plus 5. We know that. We evaluated. F bar of s equals to 1 by s plus 5. And f of 0 we evaluated as 1. Next, f dash of 0. So what is f dash of t? Where we evaluated f dash of t is minus 5 into e power minus 5t. Means f dash of 0 means minus 5 into e power 0 is going to be minus 5. Is going to be minus 5. Is going to be minus 5. So f dash of 0 equals to minus 5. Right. So now I am substituting L of f double dash of t is equals to s square into f bar of s means 1 by s plus 5 minus s into f of 0 is 1 minus f dash of 0 is minus 5. So which is equals to s square by s plus 5 minus s plus 5. This is L of f double dash of t. Okay. So like this we evaluate Laplace transform derivatives. Next. So this one, here f of t equals to 1 minus cos 2t. F of t equals to 1 minus cos 2t. Then f dash of t, differentiation of 1 minus cos 2t, 1 is 0, cos 2t differentiation, minus of cos differentiation is sine, minus 2 into sine 2t. Cos differentiation is minus sine and 2t is there and that differentiation is 2, which is going to be 2 sine 2t. 2 sine 2t. This is f dash of t. Okay. Now f of 0, what is f of 0? F of 0 means put t by 0. 1 minus cos 0 is 1, is going to be 0. Then f dash of 0 is also going to be 0. So these are all required for evaluating Laplace transform derivatives. Now I will evaluate L of f dash of t, that is s into f bar of s minus f of 0, which is equals to s into f bar of s. Did we find f bar of s? Right. Evaluate f bar of s here. So f bar of s equals to L of 1 minus cos 2t, which is equals to L of 1 minus L of cos 2t, which is equals to 1 by s minus s by s square plus 4. Okay. So f bar of s I am writing as 1 by s minus s by s square plus 4 minus f of 0 is 0. So on simplification you will get s into 1 by s is s minus s square, 1, s into 1 by s is 1 minus s into s is s square by s square plus 4. So this is L of f dash of t. This is L of f dash of t. Similarly, L of f double dash of t, L of f double dash of t means s square into f bar of s into, if you want you can simplify this actually, right? You can simplify this. So L of f dash of t equals to what we have, 1 minus s square by s square plus 4 na. That simplification leads to, means that simplified form is s square plus 1 plus 4 minus s square is going to be 4. L of f dash of t equals to 4 by s square plus 4. Now L of f double dash of t, L of f double dash of t equals to s square into f bar of s minus s into f of 0 minus f dash of 0. So which is equals to s square into f bar of s is 1 by s into 1 by s minus s by s square plus 4 minus s into f of 0 is 0, means 0, and f dash of 0 is 0. So on multiplication, s square into 1 by s is s square into s is going to be s cube by s square plus 4. On simplification, s into s square plus 4 is s cube plus 4s minus s cube is going to be 4s by s square plus 4. This is L of f double dash of t. Okay. Next, Laplace transform of integrals. When Laplace transform of integral, if L of f of t equals to f bar of s, then Laplace transform of integrals is going to be f bar of s by ds, f bar of s by s. So this is another form where you can evaluate Laplace transform, where you can evaluate integrals by using Laplace transform. So see here, integration 0 to t e power minus 4u sin 3u, integration 0 to t e power minus 4u sin 3u. So we evaluate this using Laplace transform, that is f bar of s by s. Laplace transform of integrals equals to f bar of s by s. So here f bar of s means what? L of f of t. L of f of t. F bar of s means what? L of f of t. Where L of t means? Where f of t means? What is f of t here? E power minus 4u sin 3u. E power minus 4u sin 3u. So then, which is equals to L of e power minus 4u sin 3u, which I am going to evaluate by using first shifting theorem. L of sin 3u equals to where s is shifted to s plus 4, where s is shifted to s plus 4, right? So now, which is equals to L of sin 3u means 3 by s square plus 3 square, that is 9, where s is shifted to s plus 4. Where is s is shifted to s plus 4? L of sin 3u means 3t na, sorry. So I am taking e power minus t, e power minus t, because f of t na, so means I used to write in terms of t. I have to write in terms of t. e power minus 4t sin 3t. So e power minus 4t sin 3t means e power sin 3t, where s shifted to s plus 4, that is L of sin 3t equals to 3 by s square plus 9, where s is shifted to s plus 4, which is equals to 3 by s plus 4 whole square plus 9. Okay. So then f bar of s equals to 3 by s square plus 8s plus 16 plus 9, 25. This is f bar of s. Then L of integration e power 4u, integration 0 to t e power minus 4u sin 3u du equals to f bar of s by ds, that is 3 by s square plus 8s plus 25 by s means into s. This is. Once again, Laplace transform of integrals is equals to f bar of s by s. Here f bar of s means L of f of t, where f of t is this, means e power minus 4u sin 3u, I am writing as e power minus 4t sin 3t. So then L of e power minus 4t sin 3t I am writing as L of sin 3t, where s shifted to s plus 4 by first shifting theorem. L of sin 3t formula is 3 by s square plus 9, where s shifted to s plus 4. 3 by s plus 4 whole square by plus 9. On simplification, you will get 3 by s square plus 8s plus 16 plus 9. S square plus means a plus b whole square you apply, s square plus 8s plus 16, that is s square plus 8s plus 25. Okay. And Laplace transform integral is f bar of s, so f bar of is this, by s means into s, 3 by s into s square plus 8s plus 25. Okay. Next question. So Laplace transform of L of integration 0 to t e power 4u sin square u du. So we evaluate by using Laplace transform of integrals, that is f bar of s by s, where f bar of s equals to Laplace transform of f of t, So where f of t equals to e power 4t into sin square t. E power 4t into sin square t. Then Laplace transform of f of t equals to Laplace transform of e power 4t sin square t. So which is equals to Laplace transform of sin square t, where sin square t with the exponential function, I shift s to s minus 4, where s is shifted to s minus 4 by first shifting theorem. So as sin square t is a means higher order term that you need to reduce into elementary form, that is 1 minus cos 2t by 2, where s shifted to s minus 4. Okay. So then which is equals to, I am applying a linearity property, so that is 1 by 2 I am bringing outside, then L of 1 minus L of cos 2t, where s shifted to s minus 4. So which is equals to 1 by 2, L of 1 is 1 by s minus L of cos 2t is s by s square plus 4. where s shifted to s minus 4. Okay, so which is equals to 1 by 2 on simplification s square plus 4 minus s square, that is going to be 4 by s into s square plus 4, where s is shifted to s minus 4. This is f bar of s. Still you need to simplify. Okay, so L of f bar of s I required, where f bar of s means L of e power 4t sin square t. L of sin square t, where e power 4t is represents means e power 4t into sin square t is a first shifting theorem application. So L of sin square t, where s is shifted to s minus 4. So this is a higher order term that I reduced into elementary form, that is sin square t is 1 minus cos 2t by 2. So L of 1 minus cos 2 by 2, I am by using linearity property I am writing like this: L of 1 minus L of cos 2t. L of 1 is 1 by s, L of cos 2t is s by s square plus 4, where s is shifted to s minus 4. Now which is equals to f bar of s equals to 1 by 2 into 4 by s into s square plus 4 s into s square plus 4, where s is shifted to s minus 4, where s is shifted to s minus 4, which is equals to 1 by 2 into 4 by s minus 4 into s minus 4 whole square plus 4. So which is equals to 1 by 2 into, means of course you can do cancellation. So here you will get, so 2 by s minus 4 into, so expansion of s minus 4 whole square is s square minus 8s and plus 4 square plus 4, that is 20. Okay, so this is f bar of s. So therefore L of e power 4t sin square u du, L of integration 0 to t e power 4u sin square u du is equals to f bar of s by s, that is 2 by s into s minus 4 into s square minus 8 plus 20. Okay, so this is Laplace transform of the given Laplace transform of a given integral. It can be evaluated by using the Laplace transform of integrals. Okay, similarly, evaluation of integrals by Laplace transform is very important concept. Of course, this is it's previously Laplace transform of integrals where the limits are provided 0 to t, but here in evaluation of Laplace in evaluation of integrals by using Laplace transform, means by using definition of Laplace transform. Definition of Laplace transform means integration 0 to infinite e power minus st f of t dt. So this is in the form of definition of Laplace transform. So using definition of Laplace transform, we are going to evaluate integration of this, means evaluate this integration. Now integration 0 to infinite e power minus 3t t dt. Actually, by definition of Laplace transform, what we have? Integration 0 to infinite e power minus st f of t dt. So which we represented by f bar of s. Okay, so now when I compare this with this, means L of f of t, of course. Okay, when we compare the given integral with the given with the definition of Laplace transform, it implies L of t, where s is equal to 3. See, e power minus 3t, e power minus st. F of t means t we have. In the place of f of t, we have t. So L of t, this I am writing as L of f of t. So this I am writing as L of t. where L of t is 1 by s square. Laplace transform of t by elementary functions. Laplace transform of t is 1 by s square. See, Laplace transform of t power n is equals to n factorial by s power n plus 1. So Laplace transform for t power 1, here t means t power 1, which is equals to 1 factorial by s power n plus 1, 1 plus 1, which is equals to 1 by s square, 1 by s square. So then integration of, therefore integration of 0 to infinite e power minus 3t dt is equals to what? 1 by s square, wait, here. So which is equals to, why it is coming like this? Nikhil Bhaiya? Oh, right. So which is equals to? So which is equals to? L of t means 1 by s square, where s is equal to 3, which is equals to 1 by 3 square, means 9. So this is L of, means this is integration of 0 to infinite e power minus 3t into t dt. Okay, so I just converted the given integral, means I just compare the given integral with the Laplace transform, integral Laplace transform, and in the place of s we have 3, and in the place of f of t we have t. So Laplace transform t we have by elementary functions, Laplace transform of elementary functions we have L of t is equal to 1 by s square. So in the place of s I'm just substituted by 3, so 1 by s square is equal to 9. Next, integration of 0 to infinite e power minus 4t sin 3 dt. So this also we compare with e power minus 4t sin 3t dt. So I will compare this with the Laplace transform definition, e power minus st f of t dt. F of t dt. So which is equals to L of f of t. So similarly, we represent this as L of sin 3t, where s is given by 4. S is by 4. In the place of s we have 4. In the place of f of t we have sin 3t. L of sin 3t means s by a by s square plus a square, that is s square plus 3 square, 9. So put s by 4. So which is equals to, what do you get? Which equals to 3 by, in the place of s, put s is equal to 4, you put in the place of s, then 4 square plus 9 is going to be 25. So that is integration 0 to infinite e power minus 4t sin 3t dt. Sin 3t dt is equals to 3 by 25. Is equals to sin 3t dt equals to 3 by 25. Okay. Next, e power minus 2t sin 3t. Similar way we can evaluate even this. In the place of s we have 2. In the place of f of t we have sin 3t. So then Laplace transform of sin 3t as we said that 3 by s square plus 3 square, that is 9, and substitute s by 2 is going to be 3 by 2 square is 4, that is 13, 3 by 13. Okay, next this one, e power minus 2t t sin 3t, means I will write this as L of t sin 3t. When I compare with Laplace transform definition, in the place of f of t we have t sin 3t, where s is equal to 2. So it is multiplication by t na. So minus 1 whole power 1 into d by ds of L of sin 3t. L of sin 3t. Okay, minus 1 whole power 1 means minus d by s of L of sin 3t means 3 by s square plus 9, where s is equal to 2. So minus d by ds of this means minus 3 by s square plus 9 whole square into 2s. So where s is equal to 2. Okay. Then minus into minus plus 3 by s square plus 9 whole square and 2s na. Substitute s by 2. So 2 means 2 2 is 4, 4 3 is 12. 12 by, I am just putting s by 2. Here 3 by s square plus 9 differentiation, 3 by s square plus 9 whole square into 2s. Substitute s by 2. 2 2 is 4, 4 into 2 3, 12. 12 by 4 plus 9, 13. 13 whole square means 169. 12 by 169. This is plus symbol. As minus into minus is going to be plus. So like this, we can evaluate Laplace transforms by using, we can evaluate integrals by using Laplace transform. By using Laplace transform definition. Even this also we can see L of, in the place of t we have t sin t. And in the place of s we have 1, e power minus st. S is by 1. So which is equals to minus 1 into d by ds of L of sin t. As it is under multiplication by t, so I am applying my multiplication by t rule and substitute s by 1. So minus power whole power means minus d by ds. L of sin t means 1 by s square plus 1, and where s is equals to 1. Okay, d by ds of 1 by s square plus 1 means 2s by s square plus 1 whole square, and substitute s by s is equal to 1. Okay, so then which is equals to here you will get minus 1 by s square plus 1 means minus 1 by s square plus 1 whole square, and s square plus 1 differentiation is 2s. Minus into minus is plus, and substitute s by 1, it is going to be 2 by 1 square plus 1 is 1 square plus 1, that is 2 whole square means 4. 2 by 4, which is going to be 1 by 2. So Laplace transform of this is going to be 1 by 2. Again, this is Laplace transform of t into t sin t, and s is by 1. When compare this with the definition of Laplace transform, in the place of s we have 1, in the place of f of t we have t sin t, and t sin t is Laplace transform multiplication by t rule. So that I am applying. So L of sin t means 1 by s square plus 1. Its differentiation is s, and followed by minus, so it becomes plus 1 plus, and if I substitute s by 1, it is going to be 2 by 4, which is equals to 1 by 2. So here e power minus t sin square t. So here integration 0 to infinite e power minus t sin square t na. So we can write this as L of sin square t. L of sin square t, where s is equal to 1. In the place of s we have 1, e power minus st. In the place of s we have 1. L of sin square t, which is right in elementary form. 1 minus cos 2 cos 2t by 2. L of 1 minus cos 2t by 2, which is equals to 1 by 2 into L of 1 minus L of cos 2t. Okay, as I applied linearity property here. So which is equals to 1 by 2 into L of 1 is 1 by s minus here of course we have to give s by 1. So L of 1 is 1 by s, L of 2t is s by s square plus 2 square, that is 4, and substitute s by 1. So which is equals to 1 by 2 into substitute s by 1, 1 by s is 1, and 1 by 1 square plus 4, that is 1 by 5. So which is equals to 1 by 2 into 1 minus 1 by 5 is 4 by 5. Okay, so on cancellation you get 2 by 5. This is the Laplace transform of this. Next, Laplace transform of special functions. Okay, so unit step function, where unit step function is defined less than t, means t is less than 0, the unit step function is going to be 0. For t greater than 0, unit step function is 1, whose Laplace transform is going to be 1 by s. Okay, unit step function means the function which is defined 0 for t less than 0, and greater than 0 the function is going to be 1. So a Heaviside unit step function means the function u of t minus a. For less than means t less than a it is 0, t greater than a it is 1, whose Laplace transform is e power minus as by s. Laplace transform of a unit step function. So next, second shifting theorem. So the second shifting theorem is a combination of Heaviside and a function. So what second shifting theorem I just included here. Okay, so here L of f of t is equal to f bar of s, and where here L of f of t minus a into g of t minus a. This is g of t. G of t is nothing but u of t minus a into f of t minus a. So Laplace transform of f of u of t minus a into f of t minus a is going to be e power minus as into f bar of s. So here f of t minus a with a Heaviside unit step function. With this in the combination of this function we have defined, means the function is defined with the combination of Heavisides, is a second shifting theorem. It comes under second shifting theorem. Second shifting theorem is a function with Heaviside unit step function. In such case, how we evaluate Laplace transform is discussed under second shifting theorem. So Laplace transform of g of t is equals to e power minus as into f bar of s, where g of t is u of t minus a minus into f of t minus a. Right? See, L of t square into u of t minus 1. This only I am going to discuss here now. L of t square means t minus 1 plus 1 whole square I will write into u of t minus 1. I am converting into f of t minus a into u of t minus a. So which is equals to L of t minus 1 whole square plus 2 into L of means L of t minus 1 whole square plus 2 into t minus 1 plus 1 into u of t minus a, u of t minus 1. I am expanded this. This t I am writing as t minus 1 plus 1, because here we have t minus 1. So I am trying to write t square as in terms of t minus 1. So which is equals to L of t minus 1 whole square into u of t minus 1 plus 2 into t minus 1 into u of t minus 1 plus u of t minus 1. So which is equals to L of t minus 1 whole square into u of t minus 1 plus 2 into L of t minus 1 into u of t minus 1, u of t minus 1 plus plus L of u of t minus 1. Okay, so this is here L of t minus 1 whole square u of t minus 1. So here we write this as e power minus as. Actually, what is Laplace second shifting theorem? By second shifting theorem, this is like f of t minus a into u of t minus a. Here f of t minus a means t minus 1 whole square, means f of t minus t square. So e power minus as, a means 1s into f bar of s. F bar of s means L of f of t. F of t means here t square. So in the place of t minus 1 whole square, the function is t square plus 2 into L of t minus 1. Here e power minus 1s into, in the place of t, f of t we have t. F of t minus a means t minus 1. F of t means t. Plus here L of t minus 1 is going to be 1 by s that we had. L of t minus 1. E power minus as by, sorry, e power minus as by s na, e power minus 1s by s. So L of u of t minus 1 means e power minus 1s by s. L of u of t minus a is equal to e power minus as by s na. Similarly, here a is 1, which is equals to, so here 2 into e power minus s into L of t, I have to write, plus e power minus 1s by s. Okay. So here e power minus 1s means e, which is equals to e power minus s. So L of t square means 2 by s cube. Laplace transform of t square is 2 by s cube. So 2 into plus 2 into e power minus s into L of t is 1 by s plus e power minus s by s. Okay. So you can take e power minus s common, then 2 by s cube plus 2 by s plus 1 by s. So which is equals to e power minus s into 2 by s cube plus 3 by s. We can simplify by e power minus s into s cube is LCM. So it becomes 2 plus 3s square is the Laplace transform of t square into u of t minus 1. Okay, Laplace transform of t square into u of t minus 1 is equals to e power minus s into 2 plus 3s square by s cube. Okay. So t square u of t minus 1 I am just converting into in this form. U of t minus into f of t minus a form I am just converting into. T square I am writing as in terms of t minus 1 terms and applied second shifting theorem What second shifting theorem says e power minus a is into f bar of s. F bar of s means L of f of t. So in this case f of t is t square, in this case f of t is t. So that is Laplace transform of a unit step function. We said unit step function is e power minus s by s, where a is 1 na? So that way I evaluated. Okay. So this is what I discussed. In the next class we will see further. Okay. On second shifting theorem, how we worked out the problems, that we will see in the next class. Means one problem I discussed on second shifting theorem. So similarly, we will discuss some more problems on second shifting theorem, right? Okay, now. So here, L of, if even this also comes under, means this also like f of t minus 3, u of t minus 3. F of t minus means f of t minus 3, u of t minus 3. Here a is 3. Here a is 3. Here a is 3. So then L of Here f of into by using second shifting theorem, f of t is cos t and a is 3 e power minus 3s into f bar of s. So e power minus 3s into L of cos t means s by s square plus 1. That's all. That's all. Using second shifting theorem. Using second shifting theorem, f of t is cos t. So in the place of a we have 3. So e power minus a is into f bar of s. F bar of s means L of cos t. Cos t means s by s square plus 1. E power minus 3s into s by s square plus 1. Right? Okay. Okay. So further we will see in the next class, because as time is getting over, so we will see the further sums, the further the further problems that we will see in the next class. Even this also we are going to discuss in the next class. Right? Okay. Thank you.